In a previous video, we talked about the standard way for naming branches. There are some branches, though, that themselves have branches on them, and these have common names that you wouldn't predict just using that table that we've seen so far. And so the only way you would know these names is really by having memorized them. Now, here are the branches that have these common names. We have a branch that has 3 carbons, branches that have 3 carbons, branches that have 4 carbons, and branches that have 5 carbons. So, just a couple patterns. If it forks like a snake's tongue at the end, then you'll notice that it has that iso in front. So iso. Notice it forks like a snake's tongue, iso, forks like a snake's tongue, iso. And then the other part of the name is just coming from the number of carbons in the branch. So in this top one, there's 1, 2, 3 carbons, so propyl. Prop because 3 carbons, YL because it's a branch. So isopropyl. We also saw that one with the snake's tongue. It has 1, 2, 3, 4 carbons total, so bute, and it's a branch, so YL, so isobutyl. And then for this bottom one down here, you still have the snake's tongue, so iso, but here you have 1, 2, 3, 4, 5 carbons total, so pent, and then YL because it's going to be a branch. So those are those isos. For sec-butyl, that's because you have 1, 2, 3, 4 carbons, right? So bute, and it's a branch, so YL. And the branch is connected to the parent chain on the second carbon of that, so sec-butyl. For tert-butyl, this carbon here is bonded to 1, 2, 3 carbons. 3 carbons is tertiary because it's bonded to 3 other carbons, and so that's tert-butyl. And if you just have one more carbon in between a tert-butyl and a parent chain, then you end up with this neopentyl branch. So these will show up throughout all of organic chemistry. The two that show up the most are isopropyl and tert-butyl. Tert-butyl especially is important because it's very crowded. You have a lot of methyl groups right next to each other in that group. And so anytime a textbook or a chemist wants to illustrate the effect of crowding, they use tert-butyl. It's very crowded. And the fancy term for very crowded is it has a lot of steric hindrance. So that's just fancy terminology for being very crowded. So isopropyl and tert-butyl. One other thing is we're going to see that we're going to alphabetize these names in the future. When you alphabetize these names, you don't include sec or tert. Notice those are separated by those dashes. Those are not included in alphabetization. But iso, which doesn't have a dash, you would use the I in iso to alphabetize that. Okay, that's a note for the future. Underneath the common names, they're giving you IUPAC names. You can learn those if you want. People tend to use the common names, though. And so my test would ask you for these common names, rather than for the IUPAC names for these branches. Okay, so let's do some naming with those, get some practice with identifying those. It says, for 4.7, it says, for each of the following compounds, identify all groups that would be considered substituents or branches, and then indicate the systematic name as well as the common name for each branch. You can look at the systematic names if you like. I'll show you how you can get that from this table. For our purposes, though, we're going to focus on the common names here. So in this first step is to identify the parent chain. So here you have 1, 2, 3, 4, 5, 6, 7. That's the longest chain you can find without going backwards or lifting up your pencil. So that's the parent chain. Here they're not asking for the name of the whole compound or of the parent chain. They want to focus on the name getting the names of these branches. And so here we have this branch. So which of these common branches is that? That's that tert-butyl branch. And so that you'd have that named tert-butyl. The one carbon bonded to 1, 2, 3 other carbons. It's tertiary, tert-butyl. For this next one, find the parent chain. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the longest carbon chain I can find without going backwards or lifting up my pencil. In this example, we're not trying to name that parent chain, just the branches. And you'd notice that here at the top we have a branch with a branch. And so we'd refer back to this little table, and you'd see that that would be an isopropyl branch. If you wanted to give the systematic name, it would be 1-methylethyl, but you don't have to worry about that. For me, you would use isopropyl. We do have another branch here, this one here, but that's not a branch with a branch. We would name that in our normal way. You have 1 carbon, so the prefix is meth, and it's a branch, so immediately after that prefix comes YL. Okay. If we take this next one, the longest carbon chain you can find without going backwards or lifting up your pencil would be this one right here. So our branch is this, and that is a neopentyl branch. So that branch name would be neopentyl. For D, the first thing you'd want to do is to find the parent chain. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's our parent. And so we've got 2 branches here. We have this branch. You see the snake's tongue, and it only has 3 carbons, so it's isopropyl. And then right next to it you have, again, the snake's tongue, but this time this whole thing has 4 carbons, so that would be isobutyl. So then we go to the next one, E, the last one, which we're recognizing these strange branches. Whenever you have a ring and branches, always separate them in your mind. Never cross from the ring to the branches. Ask yourself, how many carbons are in the ring? Here we have 1, 2, 3, 4, 5, 6. Then ask yourself, for each of the branches, if they were the backbone, how many carbons would you have? Well, on this one you'd have 3. And this one you'd have 3. Notice it's not the total number of carbons, it's the longest straight chain you could find without going backwards or lifting up your pencil. Here you'd have 1, 2, 3, 4. And here you'd have 1, 2, 3. So the ring has 6 carbons. The longest straight chain you can find outside of the ring only has 4, and so that means the ring is the backbone. So all the rest of these are going to be branches. So I'm going to circle the ring in purple. That's our backbone. Now let's think about, or actually, I'll circle it in pink. That's our backbone. Now let's think about each of these branches. This first branch on top, you see the snake's tongue there, so you know it's iso. Count the carbons up, you'll see there's 4, and so it's isobutyl. This next one, clockwise, you see the snake's tongue, so you know it's iso. There are 3 carbons, so it's isopropyl. This next one looks really crowded. You've got 3 methyl groups bonded to 1 carbon, and that is the famous tert-butyl. And then finally over here you have 4 carbons. It's bonded to the parent chain on the 2nd carbon. That's the sec-butyl branch. So these branches are largely a matter of memorization, but you will recognize them that you'll need to use the naming for those whenever you have branches that themselves have branches. So that's some help with recognizing and naming.